on, any second now. And we're live. Okay, and does it have the right title? It does have the right title. Okay, it's not gaming, but whatever. Welcome back. Sorry, I had to try this stream like 8 times because it's so annoying. The last time I did it, which was like an hour long, I was using my old computer, which does not have a very good headphone jack at all. So it's probably because water got in there, so it wasn't working, and now you couldn't hear any audio, but now it should work. So yeah, let's do this. I was learning from a book called The Linux Command Line, A Complete Introduction by William Schatz, 3rd edition, 2026. Thank you, William Schatz, for this epic book. How to do the Linux command line and all this stuff. So basically, I got to like chapter 3, I think. It wasn't too much that I skipped that you're probably missing. I mean, went over the introduction of like, Linux, why the command line, how to read the book, why is it called shell, what else? How to install the Linux, how to use the command line, how to use a terminal emulator, which I'm using right now, called Qterminal on LXQt. Now, I was using KDE Plasma because I love it. It's way more prettier, looks a lot better, more customization, I think. But it's a little bit too much for my computer to handle, and it was very slow. And it crashed a lot. So we switched to a very, very lightweight one called LXQt, and this thing has like very minimal everything, but it works, and it's a lot faster, and it definitely crashes way less. In fact, it hasn't crashed yet since I've installed it. It's worked pretty well. But yeah, this book basically teaches you an introduction to the command line. Not everything, but a lot. It's pretty long. It's like at least 493 pages. No, 483. So, let's get to it. Let's see. We were on page 20, which sounds far, but it's not that far. Again, the only things we learned. Let's just go through what we learned. We learned pwd, print the name of current working directory. We learned cd, change directory. ls, list directory contents. We also learned what the shell is, and also learned ls, file, determine file type, and less, which is a program that lets you view the file contents. Text-based, obviously. And that's it. So now we're going to take the guided tour. This is where I left off, I believe. Here we go. The file system layout on a Linux system is much like that found on other Unix-like systems. The design is actually specified in a published standard called the Linux File System Hierarchy Standard. Not all Linux distros conform to the standard exactly, but most come pretty close. Next, we are going to wander around the file system to see what makes our Linux system tick. This will give us a chance to practice our navigation skills. One of the things we will discover is that many of the interesting files are in plain, human-readable text. As we go about our tour, try the following. cd into a given directory. List the directory contents with ls-l. If you see an interesting file, determine its contents with file, and if it looks like it might be text, try viewing it with less. So basically everything that we did before, and putting it all to use to look at files. If we accidentally attempt to view a non-text file and it scrambles the terminal window, we can recover by entering the reset command. Remember the copy and paste trick. If you are using a mouse, you can double-click a file name to copy it and middle-click it to paste into into commands. As you wander around, don't be afraid to look at stuff. Regular users are largely prohibited from messing things up. That's the system administrator job. If a command complains about something, just move on to something else. Spend some time looking around. The system is ours to explore. There are no secrets. So table 3-4 lists just a few of the directories we can explore. there may be some slight differences depending on our Linux distro, but don't be afraid to look around and try some more. So, this is what we did. We did ls. Oh, what the fuck? Wrong key. Oh, that's page up. Wait, maybe? Hold on. Maybe I can't use this keyboard, actually. Now it's not working. Oh, shit. What the hell? Oh, no. Don't close the tab. What's going on? Okay. Open back the terminal. Can I type now? Now I can type. Okay, that was weird. It was like not working for a second. Okay. Oh, whoa. Okay. So we did ls, which lists everything in that directory you're in. So we're in the home folder. We also learned cd to go to any directory and change it. You can go via a relative path or something, or via a relative path name, or by the absolute path name. That's what it was. Usually you do relative, but if it's far away, you can do absolute. And then we use the file command to look at what the file is. So you do file, remove kde plasma, which is just AI text that I copied and pasted into a text file. And as you can see, even though it does not have the file extension txt, Linux still knows that it's Unicode text, UTF-8, whatever. But yeah, in the book it described that you don't actually need to have the file extension, like .txt, .mp3 for Linux to know what it is. But it does need it for applications, right? If some of them require you to have the right file extension. But for this, no. For the terminal, it does not. We also learned less, which lets you actually see what's inside of the, I believe. Yeah, so then we do, what was it again? B and space. Space to go up, space to go down, B to go up. See, it looks like AI text. It is. It's just how to get rid of KDE Plasma, because I needed to get rid of it. Because initially I had KDE Plasma, but can't use that. I used to use it, and to be honest, it crashed a lot, and it worked, but just not the best. I would need a little bit of a newer computer. Look at the googly eyes. I love that. You can have the cursor eyes, which are also on KDE Plasma. They just follow your cursor. It's a little desktop toy or panel toy. This one can go cross-eyed too. Anyway, so the slash directory is the root directory where everything begins. Then the slash bin contains binaries, which are programs that must be present for the system to boot and run. Note that most modern Linux distributions have deprecated slash bin in favor of slash user slash bin. So it probably isn't slash user slash bin. Let's see. cd slash user slash bin. Ooh, that's why you don't press up. Slash user slash bin. And there we are. And now, ooh, that's a lot of peoples. Yeah, that's everything in your binary or whatever. Then we have slash boot, contains Linux kernel, the initial RAM disk image for drivers needed at boot time, and the bootloader. Interesting files include boot slash grub cfg or menu.lst, which is used to configure the bootloader, and boot VM Linux, or something similar to Linux kernel. Yeah, so grub is the boot. Where is it? Grub is the bootloader that most people use. That's what I have. So basically, when I turn on the computer, instead of seeing a Windows logo, you basically just see this little rabbit thing, and then it says press escape for more boot options. But if you press enter, you'll see like all your Linux, the OSs that you installed, the distros. So for me, it's only Arch Linux. So there you go. So let's go back to, actually just press CD and it goes back home, and then press clear, get rid of all that. Oh, and also I have to do this every video, but there you go, if you needed proof. Now the thing about switching from KDE to LXQt is that some of the stuff worked pretty well, because a lot of KDE applications are still, they're Qt based. So like, I still use some KDE applications. Oops, I didn't mean to do that. But I still use stuff like, I don't know, kwrite, kwrite. I still use sometimes console, even though I have Qterminal, which is the same thing. It does the same thing. Terminal emulator. I also have, what else? else do I use? That's KDE Plasma. I think that's it. I thought I had Dolphin, but no, I use this one now called PC whatever FM. Then we have the /dev. This is a special directory that contains device nodes. Everything is a file. Also, well, that's quotations. Everything is a file, which is a saying that they use, which means that like everything on your Linux system is a file, basically. Or actually, it's a Unix-like operating system, such as Linux, is that everything is a file, which kind of makes sense. A lot of your system is basically just a bunch of files. Let's see. Also applies to devices. Here's where the kernel maintains a list of all devices it understands. Ooh, don't get me started on this stupid... Oh my gosh, okay. Kernel panic. It's not good. You don't want that. The etc directory contains all the system-wide configs files. Everything in its directory should be readable text. While everything in etc is interesting, here are some all-time favorites. /etc/cron tab, which defines the automated jobs will run on system that use cron program. fstab, ooh, fucking hated that. Generate fstab file in the Arch Linux. Fuck that part. I can't even stress how much that sucked. Because I couldn't get it to work. I don't know what's wrong with me. Yeah. If you do the Arch Linux installation via, without using Arch install, I remember that's part of the documentation that you read. It says like generate the fstab file, which is a table of storage devices and their associated mounts, points, and etc passwd, a list of all the user accounts, which I didn't see when I did that last time. I did that in the previous live stream that I deleted, and I didn't see the user accounts, but maybe it's just because it's me. Penguin IC. Anyway, /home is then each user is given a directory /home. Ordinary users can only write files in their home directories. This limitation protects the system from errant user activity. Yeah, so if you're not sudo, super user, administrator, root, whatever you want to call it, not sudo is actually the command, but which is the giving administrative permissions for one command. It's like super user do, so it's only for that one command you can give privileges to do one thing. But if you're not the root, if you don't know the password or whatever, then you can't really fuck up the system files because, it doesn't let you, I think. Ordinary users can only write files in their home directories. Yeah, that makes sense. /lib contains shared library files used by the core system programs. These are similar to dynamic link libraries in Windows, DLLs. This directory has been deprecated in modern distributions in favor of /user/lib. Makes sense. And then we have the lost plus found. I always remember that one. Each formatted partition or device using a traditional Linux file system, such as ext4, will have this directory. It is used in case of a partial recovery from a file system corruption event. Unless something really bad has happened to our system, this directory will remain empty. It's good that it's there. Let's see. On modern Linux systems, /media directory will contain the mount points for removable media, such as USB drives, CD-ROMs, and so on. Oh, I thought it was MNT. Interesting. And so on. They are mounted automatically at insertion. Yeah, because otherwise you probably have to type in the command to do that. Now there's /MNT. On older Linux systems, the MNT directory contains mount points for devices that have been mounted manually. There you go. I feel like I did that on the Arch Linux install too. Something with MNT, but I don't remember. I'm trying to forget. The op directory is the /opt directory is used to install optional software. This is mainly used to hold commercial software products that might be installed on the system. A lot of reading. Okay. Where am I at? /proc. The proc directory is special. It's not a real file system in the sense of files are stored on the hard drive. Rather, it is a virtual file system maintained by the Linux kernel. The files it contains are peepholes into the kernel. The files are readable and will give us a picture of how the kernel sees the computer. Browsing this directory can reveal many details about the computer's hardware. Okay, interesting. /root is the home directory for the root account, which I always thought of as just slash instead of /root. But, you know what though? Actually, wait. now I'm in the home. CD ... again. Now I'm in the root. So what if I go CD root? Oh, permission denied. I can't go in there. Wait. If I do slash. But I'm in there already. Wait, what am I doing? Oh, but there is a root folder. No, there isn't. Wait, I'm trying to see all these. Oh, there is. But you can't go in there. It's the home directory for the root account. Wait, but I don't have root. I am the super user. Like, I'm basically the admin of this computer. I'm the only one fucking using it, but I don't know how to get into that one. You might have to do sudo. Or I don't know. Interesting. /run. This is the modern replacement for the traditional TMP directory, seen TMP entry. Unlike TMP, the run directory is mounted using the tempfs file system type, which stores its contents in memory rather than on a physical disk. We do have run. Okay. Then we have sys. Oh no, we have sbin. This directory contains system binaries. These are programs that perform vital system tasks that are generally reserved for the super user. Note that modern Linux distros have deprecated sbin in favor of user sbin. Let's just go into user and see what's in there, because there's probably a lot of stuff that, like they said, right? CD user. Oops. Then we to ls, and we see that, yeah, there you go, sbin. Now we have lib and lib32, which I don't know if they're on here. Maybe they are. Okay. Then we have the sys directory. It contains information about devices that have been detected by the kernel. This is much like the contents of the /dev directory, but is more detailed, including such things as actual hardware addresses. That's a lot of complicated stuff. Okay. I'm going to skip a little bit of this. We have the TMP directory is intended for storing temporary transient files created by various programs. Some distributions empty this directory each time the system is rebooted. The user directory is likely the largest one. It contains all the programs and support files used by regular users. So, makes sense. User bin contains executable programs installed by Linux distro. It is not uncommon for the directory to hold thousands of programs. You know what? Let's just see. Let's go to bin. CD bin ls. Oh, that's a lot. Yep, I expected that. I don't know how to go up or down, but I mean, I guess I could use the mouse. Look at this. Look at how many there are. And this probably includes... Oh, look, there's fdisk. Fdisk. Oh, my God, I'm going to die. I fucking hate fdisk. Oh, look, ffmpeg. Was that the terminal-based... No, that's not terminal-based. File player? I know it's like a file player or something. Oh my God, there's so many freaking systems here. Look at all of this. This is pretty cool, actually. They are interesting. Thing is, I'm using my mouse. Oh, look, LXQt. This is my desktop environment. LXQt about admin user, helper, archiver, backend, backlight backend, config, brightness, runner. The runner would be this thing. I also think I have Wo-Fi installed for the file system, which I could also use for apps. But you know, the runner itself works fine. This is cool. Okay, let's keep going here. Then we have the user lib, the shared libraries for the programs. Local, user local, which is the programs that are not included with the distribution but are intended for system-wide use or installed. Programs compiled from the source code are not normally installed in user bin. Programs compiled from source code. Ooh, I think are the AUR programs compiled from the source code? I don't know if they are. Because it seems like whenever you do, like when you make, like even when you're using the AUR helper, like yay, which I do have, I feel like that takes forever. So, I don't know. I have to look that up if they are. It seems like it is, though. I mean, if you just look at the terminal while you're doing, like, when you're installing something from Yay, it takes forever, and it's like a bunch of stuff is happening. So, on a newly installed Linux system, this tree exists, but it will be empty until the system administrator puts something on it. Well, let's see if I put anything on it. What was it called again? Local? No. Oh, yeah, local. Let's go. Probably stuff on there. I've already had this. Yep. Oh, look. Games. I never installed games. Interesting. Yeah. There are stuff in there because, you know. Oh, we also learned CD ... which goes back. Anyway. Let's keep going here. User sbin contains more system administration programs. User share contains all the shared data. Used by programs in user bin. This includes things such as default config files, icons, screen backgrounds, sound files, and so on. Well, let's look at it. Oops. Whoa, that's a lot. There's Brofi. SDDM, which is my display manager, or your login screen, which is called, I think SDDM stands for something display manager. That's all I know. There's Qt6, Qterminal. I'm gonna get exposed for all my stuff I have installed. X screensaver, there you go, I installed that one too. XDD desktop portal, I think I installed that. Wire plumber, Wayland, which I don't know why that's already there, you know. VLC, Vim, which is already pre-installed most times. GTK 3.0, what else? Grub, always pre-installed. What else? That's all I can recognize so far. I see some KDE stuff, but Pavu control, Pac-Man. I mean, yeah, makes sense. Okay, so let's go back. I don't need to be looking at all that. Okay. Then we have most packages installed on the system will include some kind of documentation. In user/there/doc, we will find documentation files organized by package. Oh, I didn't know that. Let's go. CD doc. Oh, what? Look at all these things that have documentation that don't make any sense. I always needed help with some of these, but I mean, I probably wouldn't even be, you know. Let's see. Nano. Oh, there is some documentation, but it's all HTML, so it's probably like a website. Anyway, I'm not going to go into this rabbit hole, so let's just go back to home folder. Then we have var. With the exception of TMP and home, the directories we have looked at so far remain relatively static. That is, their contents don't change. The var directory tree is where data that is likely to change is stored. Various databases, principal files, user mail, and so on are located here. Var log contains log files, records of various system activity. These are important and should be monitored from time to time. The most useful ones are var log messages and var log syslog, though these are not available on all systems. Note that for security reasons, some systems only allow the super user to view log files. Oh my god, that's a lot of stuff. Jesus Christ. And then we have home.config and home.local. These two directories are located in the home directory of each desktop user. They are used to store user-specific config and program state data for desktop applications. I know that because if you go into .config, which I think you can list the hidden files with ls-a, I think that's what we learned. If you go into them, you'll see a bunch of little config files, which are like text-based, that you can edit stuff with. So like, I think I made the tux paint one there. I don't remember what else, but the tux paint one, that's how you set your window size, which I already forgot how to do that. I'll have to figure it out again because it's annoying. On Mac OS it's easy, but not on Linux, of course, because you don't know where the file is. Anyway, symbolic links. As we look around, we are likely to see a directory listing. For example, in /user/lib, with an entry like this. Oh yeah, and we also learned what the ls command can do a lot. It could list out stuff with dates, with modified, with what else? Times, which I already said. It could list out in long format, reversed. What else? And then it shows what all this stuff means. Anyway, we don't really need to know that for now. Notice how the first... Okay, wait. So we said, as we look around, we are likely to see a directory listing. For example, in /user/lib with an entry like this. So it says LRWXR, WXR, WX, whatever. One root. Oh yeah, this is when the other page was. One root. 11 2025 8 11, which would be the date, 7:34 time, and then libc.so.6 whatever, libc 2.6. So that makes no sense to you, but basically it's saying, notice how the first letter of the listing is 1 and the entry seems to have 2 file names. This is a special kind of file called a symbolic link, also known as a soft link or a symlink. In most Unix-like systems, it is possible to have a file referenced by multiple names. While the value of this might not be obvious, it is a really useful feature. Picture this scenario. A program requires the use of a shared resource of some kind contained in a file called foo, but foo has a frequent version changes. It would be good to include the version number in that file name so the administrator or any other interested party could see what version of foo is installed. Okay. This presents a problem. If we change the name of the shared resource, we have to track down every program that might use it and change it to look for a new resource name every time a new version of a resource is installed. It does not sound like fun. No. Hunting through stuff, it does not sound fun. Here's where symbolic links save the day. Suppose we install version 2.6 of foo. Suppose we install version 2.6 of foo, which has a file name foo 2.6, and then create a symbolic link simply called foo that points to foo 2.6. This means when a program opens the file foo, it is actually opening foo 2.6. Now everybody is happy. The program that rely on foo can find it, and we can still see what the actual version is installed. When it is time to upgrade to foo 2.7, we just add the file to our system, delete the symbolic link foo, and create a new symbolic link that points to the new version. Oh, because it changes the name. I see. Not only does it solve the problem of version upgrade, but it also allows us to keep both versions on our machine, because all you're deleting is actually the file. You're only deleting the symbolic link. You're not deleting foo 2.6. However, let's see. But it also allows us to keep both versions on our machine. Yeah, imagine that foo 2.7 has a bug. Damn those developers. There has been several bugs I've ran into with Linux itself, with just this LXQt and stuff. Like, it's just some things don't work as well. What is it? The audio? Something with the audio didn't work. Or maybe it's a network manager. Trying to remember what it was. But I was trying to do something and it wasn't working very well. And it was because of a bug. So let's say 2.7 has a bug and we need to revert to the old version. Again, we just delete the symbolic link pointing to the new version and create a new symbolic link pointing to the old version. So you don't have to change, every single thing because, you're just pointing to something. Because if you were to have to do that, that would be sucky. The directory listing at the beginning of this section from user/lib directory of a Fedora system shows a symbolic link called libc.so.6 that points to a shared library file called libc-2.6-so. This means that the program looking for libc.so.6 will actually get the file libc.2.6.so. We will learn how to create symbolic links in the next chapter. Great. That's cool. I wonder how to make those. Yeah, it'll tell us in the next chapter. LN creates hard and symbolic links. Okay, and then there's hard links. While we're on the subject of links, we need to mention that there is also a second type of link called a hard link. Hard links also allow files to have multiple names, but they do it in a different way. We'll talk more about the differences between symbolic and hard links in the next chapter. With our tour behind us, we have learned a lot about our system. We've seen various files and directories and their contents. One thing we should take away from this is how open the system is. In Linux, many important files are plain human-readable text. Unlike many proprietary systems, Linux makes everything available for examination and study. Is that convincing you to switch yet? It better be, because look at everything. I mean, you can literally see the files that make up your OS, which is your distro. You can look up the files that make up your desktop environment, the files that make up all the configurations of your stupid apps that you install. It's really a lot. Wow. Okay. Chapter 4. Manipulating files and directories. Now we're ready for some real work. This chapter will introduce the following commands. Copy files and directories, which is CP. What an unfortunate name for a command. But that just means copy files and directories. Then we have MV, which is move or rename files and directories. And we have mkdir or mkdir, which is create directories, make directory. Oh, my neck hurts. Oh my gosh, it's getting strained. Then we have rm, remove files and directories, and we have ln, create hard and symbolic links. You know, when I see ln, I always just think of natural log or, calculus, which does not have me thinking good thoughts about this. Anyway, let me just stop looking down. Just look up. These 5 commands are among the most frequently used Linux commands. They are used for manipulating both files and directories. Now, to be frank, some of these tasks performed by these commands are more easily done with a graphical file manager. That's true too. You don't want to be having to do a bunch of shit in your file manager, in your, files, using commands. It kind of gets annoying after a while. With a file manager, we can drag and drop a file from one directory to another, cut and paste files, delete files, and so on. So why use these old command line programs? The answer is power and flexibility. While it is easy to perform simple file manipulations with a graphical file manager, complicated tasks can be easier with the command line programs. For example, how could we copy all the HTML files from one directory to another, but only copy files? Whoa, hold on. For example, how could we copy all the HTML files from one directory to another, but only copy files that do not exist in the destination directory or are newer than the versions in the destination directory? It's pretty hard with the file manager, but pretty damn easy with the command line. And then it shows cp u, and then it has the asterisk, which I think means recursively. I don't know what that. Actually, no. -r means recursively. What does the asterisk mean? I'm trying to think of. Shoot. What does that mean in terms of file? I don't remember. .html and then destination. So. Oh, it gives you the wildcards here. Okay. Before we begin to use our commands, we need to talk about a shell feature that makes these commands so powerful. Since the shell uses file names so much, it provides special characters to help us rapidly specify groups of file names. These special characters are called wildcards. Using wildcards, which is also known as globbing, allows us to select file names based on patterns of characters. Table 4-1 lists the wildcards and what they select. Okay, so the asterisk is matches any character including none. What the freak? So that's why it used the asterisk.html. It's looking for all HTML files. Then it says there's a question mark, matches any single character. So only one character, I guess, maybe. Then it has the bracket, characters, bracket, matches any characters that is a member of the set characters. Interesting. Then we have brackets, exclamation mark characters, or brackets, what do they call that thing? The little caret symbol, I forgot what that's called. Matches any characters that is not a member of the set characters. It's this symbol. Let me type it out. That symbol. I don't know what that's called. I always think of that as like superscript too, like you put it above. Anyway. Then we have class, matches any characters that is a member of a specified class. Okay. Don't know what that means. Then we have alnum, matches any alphabetical character. No, alnum is alphanumeric, sorry. Alpha is alphabetical character, matches any numeral as digit, lower, any lowercase letter, upper, any uppercase letter. But these are going to be in brackets and colons for some reason. Wow, that is actually really interesting. Okay. Which would be none characters, huh? So we have table 4-3 wildcard examples. Actually, wait. It says using wildcards makes it possible to construct sophisticated selection criteria for file names. Table 4-3 to provide some examples of patterns and what they match. I see. So you can match. So the little asterisk by itself, meaning matches any characters including none. It's all files because it's no characters, but that's you know, that would be everything then. If it's not any specific character, that's just all the files. And then we have G with the asterisk, which means any file beginning with G. Then we have B *.txt, any file beginning with B, followed by any characters, and then ending with txt, which is very interesting. So you can get any file that starts with B. Oh, that's really specific. Then we have data, question mark, question mark, question mark, which is any file beginning with data, followed by exactly 3 characters. But does it specify what characters? Match it with any 3 characters? Any file beginning, and then there's brackets, A, B, C, and then a little asterisk. It says any file beginning with either A, B, or a C. Holy moly. So it's any of those 3. But it can't be all 3? An A, B. Oh, no. It's saying any file it looks like this. Let me show you what they're doing. So it looks like this. And then the star. But this means any file starting with an A, a B, which means like A, B, or C. You know, that's what it means. Anyhow, that's just confusing because it was italicized, but it's really hard to see. Then we have backup, .090909. All 3 of those have brackets around 09. Their own brackets. Any file beginning with backup followed by exactly 3 numerals. Holy crap. But it's 0 through 9 because it could be any, any numeral, which is 0 to 9. Then we have upper. Any file beginning with an uppercase letter, which would be 2 brackets upper with the little wildcard asterisk. And then we have any file, which would be lower, 1, 2, 3. Any file with a lowercase letter or the numerals 1, 2, 3. Oh my gosh. Oh, so that's beginning with that, and then it's just any file ending with a lowercase numeral. What? That is so weird. It's insane, these wildcards. Okay, then it says wildcards are especially valuable not only because they are used so frequently on the command line, but also because they are supported by some graphical file managers. In Nautilus, the file manager for GNOME, which I believe I used with Linux Mint, but I can't remember, you can select files by pressing Ctrl S and entering a file selection pattern with wildcards, and the files in the currently displayed directory will be selected. In some version of Dolphins and Conqueror, the file managers for KDE Plasma, you can enter wildcards directly on the location bar. For example, if you want to see all the files starting with a lowercase u in the user bin directory, enter user/bin u asterisk in the location bar and it will display the result. Huh. Okay. Many ideas originally found in the command line interface make their way into the graphical interface too. It is one of the many things that make the Linux desktop so powerful. Wildcards can be used with any command that accepts file names as arguments, but we'll talk more about that in Chapter 7. Wow. Wildcards, huh? These are crazy. And oops, I just pressed space like 1,000 times. Next page. Dot files. We already went over this, I thought. Okay, here we go. Oh, my neck hurts so bad. I'm sorry. Okay, if we look at our home directory with ls using an A option, we will notice that there are a number of files and directories whose name begins with a dot. As we have discussed, these files are hidden. It's not a special attribute of the file. It only means the file will not appear in the output of ls unless the -A or -A, which is almost all. Remember, files are case sensitive. Same with commands, I guess. Unless the A or A options are included, this hidden characteristic also applies to wildcard. Hidden files will not appear unless we use a wildcard pattern, such as dot asterisk. Makes sense. Which would be starting with asterisks? Yeah, because it starts. No. Oh, yeah, because it's dot, which means start. However, under some circumstances, depending on how our shell is configured, we may also see both dot, the current directory, and dot dot, the current directory's parent, in the results. To exclude them, we can use patterns such as exclamation mark dot whatever, or dot question question, dot question question asterisk, which seems really crazy. But that excludes those two characters from. I see. Because it would be the ls. Oh. I see. You're going to see the parent directory and the directory you're already in, which is dot. Okay. Hang on. Character ranges. If you're coming from another Unix-like environment or have been reading some other books on the subject, you may have encountered the A to Z and lowercase a to Z character range notations. These are traditional Unix notations and worked in older versions of Linux as well. They can still work, but you have to be careful with them now because they will not produce the expected results unless properly configured. For now, you should avoid using them and use character classes instead. I don't have to worry about that because I don't know any of that. Anyway, mkdir, create directories. The mkdir command is used to create directory. It works like this: mkdir directory ... Note that when 3 periods follow an argument in the description of a command, as shown here, it means that the argument can be repeated. Thus, the following command would create a single directory main dir1, mkdir dir1, while the following command would create 3 directories named dir1, dir2, and dir3. Oh, you can repeat it. I see. So it's just talking about the book. The 3 periods don't mean anything in Linux. It means like it could be done with dir1, dir2, dir3. So yeah, you can make 3 directories with 1 command, or as many as you want. I mean, directories don't actually take space up. It's basically just like there, you know. I don't think they take space unless they actually have something in them. What the hell is going on? Okay. CP, copy files and directories. Yeah, I don't know why it's called CP. Anyway, the CP command copies files or directories. It can be used 2 different ways. The following command copies the single file or directory, item 1, to the file or directory, item 2. So let's do some practice because we might as well. We can make blank files using the touch command, I think. And it doesn't even have to have a name. It could just be blank file. So let's make 3 directories in the home folder. So we have ls. So there we go. And let's make 3 directories. So we can make dir, and let's do dir1, dir2, and dir3. There we go. Nothing happens, but that's a good sign because there they are. Then we can do touch. Yeah, let's just do it in the home folder. Touch. What do I call it? Lunix. And there's, wait, Lunix doesn't, oh, yes it does. It's a blank file. Touch Lunix 2. Touch Lunix 3. So now we have 3 files to work with. And if we do file Lunix, empty. There you go. That's what it is. All right. So the CP command copies files or directories. It can be used 2 different ways. The following command copies single file or directory, item 1, to the file or directory, item 2, while the following command copies multiple items, either files or directories, into a directory. Oh, so we can, let's try this. Okay, so CP Lunix, Lunix 2, Lunix 3, and into dir1. No such file or directory. Oh, wait a minute. Wait, that almost looks the same though. Why doesn't it work? Into a directory. Wait. Cannot stat. Lunix 3. No such file or directory. Wait a minute, I did something wrong. CP. What if I want to copy Linux 1, 2, and 3 into dir 1? But I did that. Wait, why doesn't it work? Item ... Am I in the right folder? No, yeah, because Linux. Oh, well, let's just see what's in directory 1 now. Did it copy some of them? It did. So why didn't it only do 2 of them, but then it got confused at Linux 3? Huh. Interesting. Okay, well, let's just remove Linux and Linux 2. Now it's empty. So now we cd ... Now we have, let's try this again. So cp Linux, Linux 2, Linux 3. And then we can do the directory. So slash. Ooh, how do you do the tilde? Is it function? Nope. That does not work. Control? No. Function. Oh, now nothing works. Uh-oh. No, wait. Function shift? There we go. Function shift. Good lord, I'm still learning how to use this. Is it root slash dir 1? Crap. I fucked something up. There we go. Linux, Linux 2, Linux 3 slash dir 1. No such file or directory. Why does it not want to do... Oops. Oh, I didn't put cd. Why does it not want to do Linux 3, though? It should work. Do I have to do, like, a comma? Nah. Linux 1 and Linux 2, but it does not want to do Linux... Oh, it's Lonix 3! Oh, I'm an idiot. See, this is why you gotta be careful with your names. It did work. I just didn't realize that the stupid thing was called Lonix. Okay, so let's do the mv command. Lonix 3. Linux 3? Maybe that'll work. Oh, let's see now. Yes, it's fixed. So you do the mv to switch it. I already knew that command, so I didn't have to look at the book, but now we can do it. So we do, what was it? CP, Linux. Actually, let's go to rm dir 1. Actually, no. How do I do this? I don't want to delete the directory. I just want to delete what's inside of it. I don't know the commands to do it yet, so let's just do Linux 2. Now it's empty. Okay. Yeah, I don't know the command to delete recursively inside the whole... I think it's -r, but I don't want to fuck it up. So let's just do this again one last time. cd cp Linux, Linux 2, spell it right, Linux 3 into dir 1. It worked, and now we change directory into, and there, oh, wrong command. There we go, and there it is. See, everything works. Pretty easy. That took a long time to figure out, but we did it. Okay, useful options and examples. Table 4.4 lists some of the most commonly used options for CP. Copy. -A is archive, or long option ... --archive, which is another way to put, you know, the same thing. It's just a long version with the word. It says copy the files and directories and all their attributes, including ownerships and permissions. Normally, copies take on a full default attributes of the user performing the copy. We'll take a look at the permissions in Chapter 9. Don't worry about that yet. Okay. -I interactive. Before overriding an existing file, prompts the user for confirmation. If this option is not specified, CP will silently, meaning there will be no warning, overwrite the file. So you got to be careful. I would put that on every single one where you know there might be overlap. Just always put -I, so you know, like, just be careful that you don't fuck up and, like, replace a file with, you know, something that you don't want. Recursive, there it is, -R. Recursively copy directories and their contents. This option, or the -A option, is required when copying directories. Ooh, okay, let's try this then. So we go, let's change directory into dir 1. So now we have Linux 2, Linux, and Linux 3. So if we want to copy this whole directory and their contents, ooh, I see. You can also use the -A, but let's do R. So is required when copy directory. So let's, actually we can just change, we don't even need to be in here. So we can go cp-1-r into this folder, I guess. Oh, missing destination. Oh, I didn't put the destination. Let's do, there we go. Are the same file. Oh, because it has the same name. Wait, do I have to put a name? Copy directory 1. Do I put it after the directory 1 or after R? I wonder if I put it here. Let's just call it poo, and then put no such file or directory. Okay, copy directory 1. They're the same file. Yes, I know that, but I don't, oh, maybe it's because it's in the same place. I can't copy a name with the same place. Okay, let's copy it into directory 2 then. That worked. So now if we go into directory 2, we should see directory 1, and if we change into dir1, there's Linux. So it has to be, if the destination directory has the same name as the directory that you're copying, it won't work because it's just going to be like, it's going to say that they're the same file, I guess. That's weird. Only copying it. Then there's -u. When copying files from one directory to another, only copy files that either don't exist or are newer than the existing corresponding files in the destination directory. Blah, that sounded stupid. In the destination directory. This is useful when copying large numbers of files as it skips files that don't need to be copied. V, or it's -v, verbose. Display informative messages as the copy is performed. Oh, that's interesting. Huh. Why don't we try that? Let's go back to home. Let's go back home. Let's copy directory 2 into directory 3. So we do cp-dir2-r into directory 3-v, which is verbose. Oh, that's really cool. You can see everything that happened. I see. Then it copied all the Linuxes. So if we cd dir3, we can see that there's dir2, which has dir1, which has Linux. So we do cd dir2, which has dir1, and we do cd dir1, which has Linux. Crazy. Now we know how to copy stuff, which is not too bad, and you can actually do a lot with this now that I'm thinking about it because of the way that wildcards work. There's a lot you can do, you know, with just like the arguments, because you can do like copy all the files in directory whatever, but only have files that start with a fucking emoji or some shit like that, or whatever, emoticon, and then, you know, stuff like that. Very cool. Okay, let's go back, oh boy, to home, and we can delete. Actually, we'll learn the next one. Okay, table 4.5 just provide some examples of these commonly used options. So cp file 1, file 2, copy file 1 to file 2. If file 2 exists, it is overwritten with the contents of file 1. If file 2 does not exist, it is created. Oh, you can do, I see. That's cool. Okay, wait. Let's try that. Let's try cp Linux 2. So what this should do is it should copy file Linux to Linux 2. It exists, so it's overwritten with the contents of file 1. If file 2 does not exist, it is created. Well, let's just try this with Linux, and then let's try like Linux 4. Will that work? It did work, I guess. Interesting. But does it have the same contents as Linux? Wait. No, it doesn't. You know what, though? Let's actually edit Linux to be a text file. You know what? Let's make new ones. Let's do touch fire.txt, touch water.txt, and touch grass.txt. .txt. So now we have all three, right? Let's go to nano. Let's do water.txt. So then we can write in something like, this text, if done correctly, should appear in another via the cp command. And we can press control. Here we go, wrote 3 lines. So now we have water.txt. So you're going to copy the contents of the file 1, which is water, into file 2. If file 2 does not exist, it is created. What if I do cp water.txt and then do water2.txt? Will it make the same file with the same contents? Let's see. Water2, let's see, water2.txt. That's not a command. Oops. Let's just do less water2.txt. Oh, it did work. Oh my god, that's really cool. Okay. So, and then if I do cp water.txt and then I do fire.txt, let's see, does fire.txt still exist? And if I do less fire.txt, it copies whatever's in the file into the other file. What the fuck? Yo, that is something that you really can't do with it. Like, even with the graphical thing, you would have to, like, go into the file, copy its contents, and then move it to the other file. But this, you can just do it with one fucking line of text. That is cool. And I was just one command. Then we have cp-i file 1 file 2. Same as the previous command, except that file 2 exists. The user is prompted before it is overwritten. Okay, let's try it. Let's do cp water.txt, and then we do grass.txt, and then do I. Overwrite grass.txt, yes. And it overwrites it. So now if we go into less grass.txt, it should have, yep. That is so freaking cool. I mean, I know it's just some basic shit, but that, like, the fact that it could do that is just, wow. Linux command line, I guess. Okay. cp file 1, 2, dir 1. Copy file 1 and 2 into directory 1. The directory dir 1 must already exist. Oh, so we can move everything into directory 4. Let's do mkdir directory 4. So we make a new directory. Then we do cp. It doesn't move it, it copies it. Remember, it's not move, it's copy. So then we do cp water.txt, grass.txt, fire.txt, and water2.txt into dir4. And that should all be spelled correctly. So now, if we ls, we still have everything. But if we go into dir4, cd dir4, everything's here. Okay, makes sense. cp dir1 wildcard, which is the asterisk, dir2. Using a wildcard, copy all the files in dir1 to dir2. The directory dir2 must already exist. Okay, let's do this again. We do mkdir dir5. Oops, I did that wrong. Hold on. rm dir5. Cannot remove. Is a directory. Oh, wait. Shit. How do you delete a directory? I'll learn it right now. Shit. How do you delete a directory? Wait. Oh. I'm gonna have to figure that out. Okay, wait. It's fine. I could just go back. Okay, let's make dir5. dir5. This should be in the home folder. Yes, it is. There's dir5. Okay, so then we want to do copy the contents of dir4 into dir5. So we do cp dir4 slash wildcard. Copy everything in there into dir5. Omitted directory. Ooh, I didn't do recursively. I thought. Hold on. What does dir4 have in it again? dir2. Oh, okay. I probably need to do... You know what? Shit. Let me make another one. This is kind of stupid. Let's do mkdir6. Now we have dir6. Let's put in some files in there. Let's just do cp water.txt, grass.txt, dir6. Okay, now we have dir6. And then we want to do cp dir... Wait, dir5 doesn't have anything, right? I think. Oh, no, it does have stuff. Wait, what did I put? What doesn't have anything? dir4 doesn't have it. dir4 has stuff. Wait. I want to copy everything. Oh, I need a dir7 there. Holy shit. Okay, wait. Let me figure this out. I need to make a dir7 with nothing in it. Now we can copy. Okay, dir6 has stuff in it, right? It does. Okay. Now we do cp dir1. No, this would be dir6 with the slash dir7. And it works. Okay. So if you have a directory, I think you do need to put R or something because there's a directory. But now if we look inside of dir7, there is the same stuff that was in dir6. So it did work. Just weird with directories. Copy dash R dir1 dir2. Copy the contents of directory dir1 to directory 2. If directory 2 does not exist, it is created, and after the copy will contain the same contents as directory 1. If directory 2 does exist, then directory 1 and its contents will be copied into dir2. Oh, okay. Let's try this then. cp dir6 dir7 dir8. Will it be created? Ooh. R is not specified. Oh, I didn't do recursively. Shit. 7. Actually, let's do this first. 7, dir8. There, it worked. Now there should be dir8. And if we go into dir8, there's the same stuff. So dir8 works. This copies everything in there. If the directory does exist, then the directory 1 and its contents will be copied into dir2. So let's make a dir9, and as we do cp dir8, we have to press R, I forgot. dir8, dir9. Now if we ls, we go into dir9, oops, cd dir9, oh my god, dir90 is not a directory, there's dir8, so it actually copies the directory inside of it. If it doesn't exist, it will just make a new directory with the stuff inside of the previous directory, which is very interesting. Because recursively, it's interesting. Recursively copy. You need to do that if there's directories. Okay. So with probably the wildcard thing then, I probably did need to do R for that wildcard thing to work before. You know, I don't even know where it is anymore. But if I was to do the wildcard thing, it would have to be with, it would and there was a directory inside of dir4 or whatever. It's like, let's see if I do mkdir dir10. Oh, I made it accidentally inside of whatever. Let's do dir10. Now we have dir10. I don't even know where it is. Oh. And we wanted to copy dir4, you'd have to put dash R and then do dir4. And then you can do the wildcard. Actually, it would be whatever's inside of dir4. So dir4 slash that inside of dir10. This should work, right? Because it has a directory inside of dir4, I think. Yeah, did dir4 have directories? It did, so it had dir5. So if I do, now if I look inside of dir10, it should have all this stuff. Oh, that's amazing. I figured out how to do that. Okay, so I'm not going to remember this all, but it's nice to know now, you know, how copy works. Probably going to forget. Anyway, go back. Let's just go back. We can delete all those directories in a bit. Now we have the mv, move and rename files. The mv command performs both file moving and file renaming. Let's see if I can find my renaming. When did I rename something? I feel like I did it with move. Didn't I have Linux and it didn't work? I did. No such file or directory. Yeah, MV Linux to Lunix. That's how I did it. Look at how many commands I already typed in. Anyway, let's continue on. Oh, hopefully the stream is still going. Let's check on this. Yeah, it's actually still going. Okay. Fuck. Okay. So, the MV command performs file moving and renaming, depending on how it is used. In either case, the original file name no longer exists after the operation. MV is used in the same way as CP, as shown here, so remove or rename the file in directory item 1 to item 2. Okay, to remove or rename the file or directory item 1 to item 2. Or move one or more items from one directory to another. Okie dokie, let's make another directory. So we have directory 11. Let's try to move Linux. Let's try to move Linux 2, Linux 3, Fire, and Grass into there. So now it'll actually disappear from this home folder. So if we do move Linux 2, Linux 3, Fire.txt, Grass.txt, just so I can specify, and sure, Linux 4. All into dir 11. Will this work? It did work, okay, and now they're all gone. cd dir 11, it should be there. Oh my god, yeah, it worked. Okay, so that worked. Let's try to rename something. Let's go back into dir 11. Let's see, let's try to rename fire.txt. So let's do mv fire.txt and just type in a different name. So fire, let's try pk psi fire. Will that work? I don't think that'll work. Oh, it did work. Oh, and it should have the same stuff in it, right? So if I do less psi fire.txt, yeah, it still has the same stuff in it. Okay, so now, useful options and examples. MV shares many of the same options as CP as described in table 4-6. -I interactive before overwriting an existing file, prompt the user for confirmation. -U update. When moving files from one directory to another, only move files that either don't exist or are newer than the existing corresponding files in the destination directory. Yeah, that was on the CP command as well. Verbose displays information as move is performed. But it literally happens instantaneously. Like, maybe unless your file is huge, like copying it and moving it, that stuff happens just like bam, bam, bam. Now we have MV file 1, file 2. Move file 1 to file 2. If file 2 exists, it is deleted and file 1 is renamed file 2. If file 2 does not exist, file 1 is simply renamed file 2. In either case, file 1 ceases to exist. Okay, interesting. So if you have a file, it is deleted and file 1 is renamed file 2. So if I move psi fire, actually if I move Linux to psi fire, psi fire will be deleted and Linux will be renamed psi fire. Let's try that actually, because that's an interesting. So now this should have just psi fire, and it should have whatever Linux had in it, which was nothing, because I think Linux was empty. Yeah, except now psi fire. Actually, I don't know if psi fire does have anything. It's empty. Yeah, because it was deleted basically. File 1. Yeah. If file 2 does not exist, it is renamed. Okay, that's interesting how if you copy some file, it will get the name of the second file. Or actually it's not copying, it's moving. Because why would you move a file into another file? It's kind of like a weird scenario. And then we have move I. Same as the previous command, except that if file2 exists, the user is prompted before it is deleted. Okay, let's try that again. Move I, and then let's try Linux 2 into PSI Fire txt. Overwrite PSI Fire, and you can press no, and it won't do it. Okay. Then we have mv file1, file2, dir1. Move file1 and 2 into directory 1. Directory 1 must already exist. mv dir1, dir2. If directory 2 does not exist, rename directory 1 to directory 2. If directory 2 does exist, move directory 1 and its contents. Well, you don't have to do recursively into directory 2. If it does exist, move everything. Okay, so if you want to rename a directory, you also use the move command. So let's just do cd back. Let's rename directory 11 to dir67, which is not a funny joke. Oh, I didn't put move. dir11 to dir67. Now we go into, and it should have everything. Yep, okay. Makes sense. Works as it should. That's good. Finally, we have RM. This actually is a very long chapter. I might have to stop before I get to doing the symbolic and hard links, which is okay. It's okay. CD Playground. Wow, there's a lot of shit. Holy moly. And then we do the commands. Oh, we have the man info. What is? Which CD? Okay, no. Don't get confused. The rm command is used to remove files and directories, as shown in the following examples. Here, item is one or more files or directories. Useful options and examples. Table 4-A describes some of the common options for RM. Interactive, blah, blah, blah. Recursively delete directories. This means that if a directory being deleted has subdirectories, delete them too. Oh, shoot. So if you wanted to delete a directory, you couldn't just do rm dir11, right? Yeah, it's not going to work. You actually need to do rm r dir11. And then, oh, still doesn't work. Oh, am I in the wrong file? Oh, I renamed it. I'm dumb. Okay, wait, but then if I do rm dir67 is a directory. Yeah, so then you need to do rm-r dir6, and then it works. So, yeah. This means that a directory being deleted has subdirectories. It will also be deleted. So recursively deleted. This means that if a directory being deleted has subdirectories, delete them too. What if? It doesn't though. You still need to use the R command if you want to delete a directory. So let's actually just get rid of everything. We need to delete like all of these directories low-key. Let's do rm r dir1. Actually, wait, before we do this, let's ls so we know what we have. So do rm -r dir1, dir2, dir10, dir3, dir4, dir5, dir6, dir7, dir8, dir9. I think that's it. That should be everything. Yeah, this should be all of them. And here we go. We also have force. Ignore non-existent files and do not prompt. This overrides the -- interactive option. Oh my god. Oh my god, rm silently deletes files if it's not specified. So if I just put rmi, it will ask, really remove it? Do you really want to do it? Yes. Okay. If you don't have it, it's gone. And you can't recover rm. If you do it through the terminal, it says here, it will not. Oh, and then it says verbose. So we already know what that means. Displays informative messages. We already saw that. Be careful with rm, it says. Unix-like operating systems such as Linux do not have an undelete command. Once you delete something with rm, it's gone. Linux assumes you're smart and know what you're doing. Yeah, so if you're deleting files with rm, be very careful. Because you can't get them back. Be particularly careful with wildcards. Consider this classic example. Oh god. Let's say you want to just delete the HTML files in a directory. To do this, you type the following: rm, blah blah blah, *.html. This is correct, but if you accidentally place a space between the asterisk and the HTML like so, the rm command will delete all the files in the directory and then complain that there is no file called HTML. Oh shit. Uh-oh. Yeah, because there is no file called .html. But if you put it with a space, it's assuming that you have, it's like a wildcard. But like we read previously, that wildcard can be used with any, it's like any character, right? Where was the wildcard thing? There we go. Matching any character, including none. So if there's no character, which would be a space, most files don't have spaces, right? I think. Yeah, or if it's just literally that. It's all files. Oh god. That's why it would just delete all the files. Phew. Careful with that, I guess. Where was the one where it was like maybe it was emulator? Oh no. Copy directory 1. Oh, okay. Yeah. And then complain that here's a useful tip. Whenever you use wildcards with RM, besides carefully checking your typing, test the wildcard first with ls. What? This will let you see the files that will be deleted. Then press the up arrow to recall the command and replace ls with rm. So you can list files with it. You can also do ls, and then you can do all those arguments with the wildcards with ls instead of rm. So you can like list all the files that have .html or whatever, which is also really cool. Like that's a really powerful tool, because if you have a giant ass folder and you just need to find certain things, you know, look, it'll see which ones you'll delete, and then once you know, okay, this is right, then you press, you know, up arrow to recall the command, because it remembers, apparently according to the book, most of them remember up to 1,000, which is fucking crazy. And then you can remove as needed. But be careful, because RM does not have a, it doesn't even have a, are you sure, unless you freaking put it. It doesn't even, you have to type, are you sure, which in itself, if you're typing the command, it seems like you would already know, like, yes, I'm sure. I don't know, it's weird. But anyway, table 4-9 provides some examples of using the rm command. Then we have rm file 1, then we have rm I file 1, rm-r file 1 dir 1, delete file 1 and dir 1 and its contents. So you're deleting file 1 and dir 1 and all of the stuff inside of it. So that's a lot. That would be like if I say I made, let's do this real quick, mkdir dir 1, we're going to redo dir 1, so now we have dir 1 again. Then we go into dir 1 just to make it easier, and then we do touch let's do shit 1, shit 2, shit 3. Right, we have 3 files. They're all blank. Let's say we do go back into our home directory, and we can get rid of water2. So we do rm r water2.txt and dir 1, and it will just do it silently. So now we don't have dir 1 or water2. So then we have rmrf. What was that command that deletes everything? Was it like sudo rmrf and then like the wildcard and then like slash or something like that? And it'll literally delete like all of the files in your entire root folder. This is why you gotta be careful with rm. Okay, same as the previous command except that so it was rm-rf file 1 dir 1. Same as the previous command except that if either file 1 or dir 1 do not exist, rm will continue silently. What? What does that even mean? So we'll just erase the other one if it doesn't. What if both of them don't exist? What does that even mean? That's kind of scary. I don't want to do that. I'm kind of scared with rm. What is rf? Does that mean like force? Oh yes! Recursively and then force, because f is force. Ignore non-existing files and do not prompt. Oh shit, so if you do sudo rmrf whatever for your whole thing, it would just silently do it. It will not prompt you, and it will force itself to delete everything. So you can literally make Linux nuke itself with this command shit. You can make it nuke its entire... That's crazy. I love this thing. Now we have in create links. Okay, we're going to stop there, because now we're doing the hard links and symbolic links, and oh my god, that's going to get too much. So we are going to pause there. We're on page 32. Actually, pretty good progress so far. I'm tired of reading. Thank you so much for watching this long live stream, and I will see you guys in the next one to continue our journey on learning the Linux command line, which is awesome, and it was very fun, and I love using the RM command. I'm going to RM my life now. Bye.